transforming a DJI Inspire 2 for true acro mode and maximum performance. Understanding the Inspire 2's limitations. The DJI Inspire 2 is designed as a stable aerial cinematography platform, not a freestyle acrobatic racer. By default, it uses GPS and gyro-stabilization to limit attitude angles and prevent flips. Unlike an FPV racing drone, the Inspire 2 has fixed-pitch propellers and cannot produce upward thrust when inverted. In fact, the stock flight controller will throw an error if the aircraft goes fully inverted. These safety mechanisms make true acro mode, full manual, no auto-leveling, impossible without modifications. To achieve acrobatic flips and rolls, we must bypass or modify the Inspire 2's built-in stabilization and restrictions. Key stock limitations to overcome. Auto-leveling. The Inspire 2 always self-levels using accelerometer data, preventing full manual control. GPS and attitude limits. Even in ATTI or sport mode, DJI firmware imposes bank angle limits, e.g. 35-degree tilt in GPS mode by default, and uses GPS to hold position. Inversion failsafe. The flight controller is not coded for inverted flight. If the IMU detects inversion, it triggers failsafe or motor cutoff to avoid falling out of the sky. Motor/prop constraints. The Inspire 2's motors/ESCs are not intended to reverse thrust. There's no collective pitch, sustained inverted hover is not possible. Acro flips would rely on momentum and timely righting of the aircraft. Heavy frame. At 3.4 kg, the Inspire 2 is much heavier than an FPV racer. It has slower motor response and greater inertia, making manual acro flying more challenging and risky. Despite these challenges, the drone hobbyist community has developed advanced hacks, both software and hardware, to unlock full manual flight on the Inspire 2. Below we outline the most effective methods to enable true acro mode and boost performance, along with the tools, upgrades, and risks involved. Software hacks to enable full manual, acro, mode. 1. Parameter tweaks via DJI Assistant 2, debug mode, or drone hacks. The Inspire 2's firmware contains hidden parameters that can be modified to relax or disable stabilization. By enabling the debug/developer mode in DJI Assistant 2, version 1.1.2 is commonly used, or using the third-party drone hacks tool, pilots can edit these parameters. One proven tweak is to disable the accelerometer leveling, effectively flying on gyro-only rate control, no auto-level. On older firmware, V01.00.0330, users found that setting one ACC parameter in Assistant 2's debug menu allowed the Inspire 2 to flip in flight. In other words, the drone no longer self-corrects to horizon, giving a true manual mode similar to Betaflight Acro. Pilots who have done this report the Inspire 2 can flip and roll like an FPV drone, with enough space and skill. However, this requires downgrading to older firmware and should only be attempted by very experienced pilots. The modified Inspire becomes extremely responsive and will fly faster, fall faster in manual mode. Drone Hacks software. Drone Hacks, PC software, provides a user-friendly interface to access these hidden parameters without manual config file hacks. It essentially exposes DJI's internal flight controller settings, borrowed from Assistant 2 debug. With Drone Hacks, one can search for parameters like attitude limits, enable ATTI/manual modes, remove no-fly zones, etc., and change their values on supported firmware. For example, increasing G_mode_sport_CFG_tilt_ADI_range, max tilt angle, from the stock 35° to 40+° allows steeper banking, a partial step toward acro. More aggressively, setting accelerometer usage to 0, if available, would disable leveling entirely. Always document original values before tweaking, and change only one variable at a time to evaluate effects. No Limit DroneAce, NLD, Mod Client. NLD is a popular modding suite that automates many of these hacks. It can downgrade firmware, to get to hack-friendly versions, unlock parameters, and remove various limits via a GUI. As of NLD 2.6, Inspire 2 support includes removing NFZ, no-fly zones, altitude limits, increasing max speeds, and enabling parameter edits. NLD essentially patches or installs firmware that accepts the desired mods. Many pilots use NLD to roll back to firmware v01.02.0500 or earlier, since DJI's later updates closed off debug mode and added restrictions. Once on a compatible firmware, full manual mode hacks become possible. Note, NLD is a paid tool and requires purchasing a license key, but it simplifies the process for non-programmers. Superpatcher scripts. An open-source alternative to NLD is the DJI Superpatcher project on GitHub, by Brett8883. This is a Windows batch script that automatically patches the flight controller firmware in place. Superpatcher supports Inspire 2, firmware v01.02.0200, and can unlock features beyond DJI's factory settings. For instance, it removes height and geofence limits, and even allows the Inspire 2's motors to start if the aircraft is inverted, a safety lockout normally. Enabling motor start while inverted means the FC won't shut down in a flip or crash scenario, a necessary condition for attempting acro flips without the drone panicking. Superpatcher also offers options like forcing FCC power for greater signal strength and disabling low battery autoland. It's a powerful script for liberating the drone and is widely tested. Using it still carries risk, but it's well documented and community supported. Custom firmware flashing. Advanced users have even manually edited firmware binaries to alter flight behavior. This can be done by dumping the FC firmware via tools like DUMLDOR and editing values, then reflashing. However, with the availability of drone hacks and Superpatcher, manual hex editing is rarely needed. Always ensure any firmware you flash is meant for your exact model/version. Flashing incorrect or corrupted firmware can brick the flight controller. A stable modded firmware, like those provided by NLD or Superpatcher, is preferable to random experimental builds. 2. Bypassing GPS and attitude limits. To truly fly acro, you'll also want to disable GPS position hold and any automatic braking or leveling. The Inspire 2 does have an ATTI mode, attitude mode, that can be enabled via software if not already accessible. This turns off GPS lock so the drone won't auto-brake against drift. Typically, in DJI Go 4 app settings you can enable multiple flight modes, which allow switching to ATTI. If the transmitter has a 3-position PSA switch, the A position would give ATTI mode, no GPS. However, ATTI still auto-levels the aircraft, so it's not full acro. Through parameter hacks, some have tried to repurpose tripod mode or sport mode into a manual mode. For example, on Mavic series, changing a mode's behavior to manual was done by flipping a flag in parameters. Similar might be possible on Inspire 2, but documentation is scarce. It's safer to simply disable the leveling as described above, essentially creating a de facto manual mode when in ATTI, accelerometer ignored. Additionally, increasing the attitude angle limits is important. By default, Inspire 2 limits pitch/roll, e.g. 30° in GPS, 35° in sport. Using the assistant to debug, pilots have set tilt limits up to 60° or even removed the cap, so the drone can pitch full forward, allowing high-speed dives. One community-recommended enhanced sport mode recipe, for example, set g_mode_sport_cfg_tilt_range equals 43, versus 35 stock, among other velocity and acceleration boosts. Pushing it further, 90+°, could enable quasi-flips, but the real barrier was the auto-level code. Thus the consensus hack for true flips was indeed disabling the leveling, the Euro-only trick, on firmware 0.330. To reiterate, only attempt full manual control if you are an expert FPV pilot, as the Inspire 2 will have zero self-correction and will not stop tilting at 90°, it will flip over if you continue a roll input. Recovering requires skill and altitude. 3. Removing system safeties. Other software tweaks to maximize performance include turning off obstacle sensing and upward sensor limits, which could interfere during aggressive maneuvers, and disabling any automatic geofencing that might kick in and restrict movement. Tools like NLD and drone hacks allow disabling no-fly zones, NFZ, and altitude limits easily. For example, you can set g_config_flying_limit_height_limit_limit_enabled equals 0 to remove the 500 m height cap, or set NFZ parameters to allow flight in restricted zones, bearing in mind legal responsibilities. Another important parameter group is the attitude gains and braking sensitivities. When flying manual/acro, you may want to adjust the gain on pitch/roll/yaw so that the Inspire responds more quickly to stick inputs, or conversely, you might want to soften them to make the heavy drone less twitchy. Some modders increase the max yaw rate and decrease braking gain so that the drone doesn't aggressively try to stop when you center the sticks. Essentially, you are retuning the flight controller for acrobatic agility at the cost of stability. These changes can be done in Parameter Editor or sometimes within DJI Geo's gain settings, to a limited range. Always test incrementally, small changes can have big effects on such a large aircraft. In summary, the software path to Inspire 2 Acro mode involves firmware downgrades and parameter hacks. Use Drone Hacks or NLD to get on a moddable firmware, then tweak parameters to disable leveling and raise angle limits. Community members have demonstrated successful flips with this method. Be aware DJI does not support this, you are effectively overriding the flight controller's safe operating envelope. The reward is true manual freedom, the risk is loss of control if you're unprepared. Hardware modifications and flight controller upgrades. In addition to software hacks, some enthusiasts consider hardware modifications to achieve or improve acro performance. This can range from adding supplementary components, like an FPV camera or antennas, to outright replacing the Inspire's flight controller with a third-party system. Below are the main hardware-centric approaches. 1. Integrating a secondary flight controller, Betaflight/iNav/Pixhawk. In theory, one could strip out the DJI flight controller, or bypass it, and install an open-source FC, like a Pixhawk running ArduPilot/PX4, or an F7 board running Betaflight/iNav, to control the Inspire 2's motors. This would give complete acro mode capability because those firmware are built for manual flight. In practice, this is an extremely complex hack with significant drawbacks. Members of the Inspire community have inquired about converting an Inspire to Pixhawk, but the idea was largely shot down. The Inspire 2's architecture is highly integrated, its motors and ESCs communicate with the DJI flight controller, an A3 class FC, over proprietary CAN bus, and the dual battery power system and camera/gimbal are all tied into DJI's control modules. Replacing the brain means losing or re-engineering a lot. The stock ESCs would need a signal interface that a Pixhawk can provide, maybe PWM or D-Shot. DJI ESCs might not accept standard PWM out of the box. You might have to swap out the ESCs for hobby ones that can handle the Inspire's motors, a non-trivial hardware swap. The retractable landing gear and camera gimbal systems are DJI proprietary. A custom FC would not know how to drive the landing gear. You could leave the landing mechanism fixed in one position or control it via a separate circuit, but it's added complication. The Inspire's intelligent batteries communicate with the DJI flight controller. A Pixhawk won't read the battery data without a custom interface, though projects have sniffed the communication for Inspire batteries. Alternatively, one could bypass the DJI batteries entirely and use a custom LiPo, which, as discussed later, some have done. Telemetry and remote link. Using a non-DJI FC means you can't use the DJI Lightbridge feed for control/telemetry in the usual way. You'd likely install an RC receiver, FrSky, Crossfire, etc., to control the Pixhawk, and use a separate video transmitter for FPV feed. Because of these challenges, no documented full Pixhawk conversion of an Inspire 2 exists publicly, at least not a plug-and-play success. On forums, even experienced users said it's not worth the effort. One creative suggestion was to mount the Inspire 2's camera/gimbal onto a completely different drone frame that is Pixhawk controlled, essentially carrying the Inspire as payload. That underscores how integrating Pixhawk directly into Inspire was seen as impractical. That said, if one were very determined, they could treat the Inspire 2 like a custom heavy-lift quad frame, get the flight controller, install new ESCs and an FC board. Our DJI would be a good choice for a heavy quad. It handles GPS, big batteries, etc., and has an Acro mode as well. Beta Flight is more oriented to smaller Acro quads and doesn't support retracts or camera control at all, so it's less suited here. An iNav or our DJI setup could theoretically run an Inspire 2 airframe and give you full manual control plus GPS modes, but you'd lose DJI-specific features, no DJI Go integration, no smart features, and the ZenMuse camera would not work except perhaps as a dumb FPV feed. Unless your goal is purely to use the shell and motors of Inspire for a Frankendrone, this path has limited appeal. In summary, it's possible to install a third-party flight controller, but the lack of documented success suggests focusing on software mods to the existing DJI controller is the preferred route. 2. Boosting FPV capability, low-latency camera and video link. A critical upgrade for flying Acro is a better first-person view, FPV, feed. The Inspire 2's built-in FPV camera, the forward-facing NAV camera, is a small 720p unit with significant latency and poor image quality, meant only for basic navigation. It's far from ideal for fast manual flying through obstacles. To fix this, modders add their own FPV camera and transmitter. DJI Digital FPV System. One popular mod is mounting a DJI FPV Air Unit or O3 unit on the Inspire 2. For example, the Skycam modding team installed a DJI FPV Air Unit, with its 1080p/120 fps camera and low latency, on the Inspire 2 and achieved manual flips. They powered the Air Unit by tapping the Inspire's power leads, with a voltage regulator to step down to 12V, and mounted the FPV camera on the nose. The Air Unit's dual antennas were fitted onto the drone's body for good signal. You can see them protruding in the image below. This setup lets you use DJI FPV goggles for a real-time view with minimal latency, essentially flying the Inspire 2 like a giant FPV drone. Dual operators have even used this. One pilot flies via the FPV Cam in Acro mode, while the camera operator uses the main gimbal for filming. Above, a DJI Inspire 2 modified with a DJI FPV digital system. A low-latency FPV camera, bottom front, is mounted where it won't be obscured, and two FPV antennas are installed on top of the shell for signal reception. This allows the pilot to fly in manual/acro mode through FPV goggles with a responsive live video feed. Analog FPV system. Before digital FPV was common, some users fitted analog 5.8 GHz video transmitters and cameras to the Inspire 2. An analog FPV camera, like a RunCam or Foxer, can be attached to the airframe, often on the nose or atop the drone, transmitting to standard FPV goggles. Analog offers 30-40 ms latency, which is good for Acro, though image clarity is lower. The benefit is simplicity and lightweight. Power can be drawn from a balance lead or the drone's power distribution with a regulator. There are 3D printed mounts available, as mentioned in the Design and Tune blog, to attach these components cleanly. Whether digital or analog, adding a dedicated FPV feed is highly recommended, relying on the Inspire's LightBridge 2 feed, which can be 100-200 ms latency and tends to lock to the gimbal, would make Acro flight very difficult. Camera mounting considerations. When mounting an FPV camera on the Inspire 2, ensure it's secured and isolated to prevent jello. Vibrations can blur the FPV feed. The Inspire's frame has vibration damping for the main gimbal, but your FPV cam might be hard-mounted, so using foam or soft mounts can help. In the example above, tape was used to shim the mount and avoid jello. Also, the camera's field of view, FOV, should be wide enough, 120-150 degree, so you have situational awareness in Acro, and you may want to angle it up a bit, so you can see forward when the drone pitches down in fast forward flight, standard practice in FPV drones. Power supply. As noted, tapping the Inspire 2's power requires care. One mod guide shows soldering leads onto the main battery wires before they enter the arms, then running that to a Pololu step-down regulator, 12V output, for the Air Unit. This avoids using the drone's AUX power ports, since Inspire 2 doesn't really have an auxiliary power out like larger mount race drones do. Make sure any added power draw is within safe limits. The Air Unit draws up to 8W. The Inspire's batteries are high capacity, so that is minor, but it will slightly reduce flight time. Always properly insulate any taps into power to avoid shorts. 3. Signal range and control mods. Flying acro often means you might push the drone further or in challenging signal conditions, e.g. flying low to the ground or around obstacles. The stock Inspire 2 uses DJI's Lightbridge 2 system on 2.4 GHz, with 5.8 GHz backup, for control and video to the remote. Its range is quite good, a few kilometers. But for maximum performance and reliability you can consider signal boosting mods. High-gain antennas. Products like the 4Hawks Raptor antenna kits allow you to replace the stock remote controller antennas with a panel or helical antenna that focuses the signal and increases gain. For example, 4Hawks makes a dual-band high-gain antenna specifically for Inspire 2 that can add several dB of gain on both 2.4 GHz and 5.8 GHz. Users report significantly extended range and stronger video link when using such antenna upgrades. The downside is a narrower beam, you have to aim the controller more carefully at the drone. Signal boosters, amplifiers. Another approach is adding an external RF amplifier, e.g. Alientech or similar boosters. These are attached in line with the RC's antennas and amplify the transmission power. Alientech even offers specific kits for Inspire 2 controllers. Regulatory note: boosting beyond FCC limits may violate local radio laws, so use responsibly. Also, boosted signals can drain the controller battery faster and add weight. Some boosters have their own battery pack. FCC mode and parameters. If you're in a region that by default uses CE mode, lower transmission power, you can hack the drone to force FCC power mode for better range. Both DroneHacks and NLD provide FCC unlocked toggles. There's also a parameter, often something like g_config_com_uplink_max_power or region code, that can be set to unlock full power. Ensure you apply this to both control and video link if separate. The NLD client's signal boost essentially forces FCC mode and can even apply a mod, boost mode, on some drones, though on Inspire 2 the published features list shows signal boost as not supported on some firmwares. So you might manually do the FCC tweak via parameters or use DroneHack's free tier to set region to FCC. Alternate controllers. One more exotic option, using DJI's Sendance controller with high-gain antennas, or even ground stations. The Inspire 2 is compatible with Sendance, which has removable antennas that you can swap for higher gain or patch panel setups. It also has ports to connect to extra devices, like a secondary video downlink. For pure acro flying, the stock controller with mods is usually fine, but if you need the absolute best link in complex environments, a ground station or diversity receiver setup could be explored. Just keep in mind range mods primarily help with distance. For acro you're typically not flying miles away, but rather need a robust signal when doing fast maneuvers, which can cause momentary signal dropouts if the antenna orientation is bad. Always point the RC antennas perpendicular to the drone for best reception, and consider diversity antennas, one omni, one patch for example. 4. Power and propulsion upgrades. To maximize performance, ensure the Inspire 2's propulsion can deliver peak thrust without limitations. DJI has built-in safeguards that reduce power if the battery can't handle the load, to prevent voltage sag. An infamous message is propulsion output limited to protect battery, which can kick in during aggressive climbs or acro moves, especially if batteries are old or cold. 2 hardware mods address this. High-performance battery packs. Using the stock TB50/TB55 batteries, you are limited by their discharge rate. The Inspire 2 LiPo Caddy is a device created by the community that allows using regular high-C LiPo packs in place of DJI batteries. This adapter speaks the Inspire's battery communication protocol so the drone thinks it has a DJI battery, while actually drawing from a pair of hobby LiPos. By using LiPos with higher discharge, e.g. 26S 10,000 mAh 25C packs, the voltage stays more stable under load. Users report no more power-limited errors and the ability to punch the throttle harder. The Caddy also reduces cost, since hobby LiPos are cheaper than DJI intelligent batteries, and it can extend flight time if you use higher capacity, with weight trade-off. The drawback is the loss of self-heating, so you must warm the LiPos in cold weather, and the Inspire's power button no longer functions. Power is applied by plugging in the external batteries directly. This mod is for advanced users, but it directly addresses performance throttling. Propellers: the Inspire 2's stock 1550T propellers are optimized for stability and efficiency. There may be aftermarket props, carbon fiber, slightly different pitch, which claim better performance. Some users experimented with Inspire 1 propellers or similar. However, be cautious, the ESCs are tuned for specific prop inertia. Changing props might introduce oscillations or stress the motor/ESC. If any community-tested prop upgrades exist, they would be found on forums. Most performance prop talk for Inspire revolves around ensuring props are in good condition, no chips, balanced, and possibly using the larger DJI 1550T propeller guards, which also increase prop size slightly. But unlike racing quads where tri-blades and different pitches abound, the Inspire's choices are limited. It might be best to stick with OEM props for reliability, unless a reputable source has proven a particular alternative yields more thrust. Motor cooling: pushing motors hard in acro flights will heat them up. The Inspire 2's ESCs do monitor motor current and temp. If you plan repeated aggressive maneuvers, consider giving the motors time to cool between flights, especially on hot days. There's not much in terms of hardware to upgrade here, short of swapping motors, which is not common. Just keep them clean and maybe apply a tiny drop of lubricant to the bearings if appropriate. Some hardcore modders drilled extra ventilation or removed some shells for weight reduction, but that's marginal gain for significant effort. Tools, resources, and community knowledge. Undertaking these modifications requires research and care. Fortunately, there is a passionate community of drone hackers and plenty of resources to guide you. Below is a list of tools and resources to assist in an Inspire 2 Acro transformation. DJI Assistant 2, PC/Mac, the official DJI utility, but use version 1.1.2 or similar for parameter editing. Enable debug mode by editing its config file, or use drone hacks to avoid that. In debug mode, you can view and modify hundreds of flight controller parameters. This is powerful but dangerous. Always note defaults and only change known parameters. Common parameters to adjust have been documented on forums, e.g., tilt_ADI_range, vertical speed limits, etc. as shown above. Drone Hacks, a third-party mod tool with a friendly UI. It offers a free parameter editor, no license needed just to use that feature, and paid features for unlocking NFZ, FCC, etc. It works for many DJI models including Inspire 2. Drone Hacks simplifies entering and saving parameter changes, and it incorporates the Assistant 2 debug functionality in one place. It's a good starting point if you're uncomfortable editing config files manually. No Limit Drones, NLD. Mod Client, a commercial software for DJI mods. NLD is essentially a one-stop program to handle firmware downgrades, parameter tweaks, and various unlocks. For Inspire 2, NLD provides firmware version management and guides you on which features are available on which firmware. It also can apply boost, FCC power, and remove speed/alt limits. The NLD community, forums on their site, share tips on the best firmware, e.g., many stick to v01.02.0500 or 0.0300 for modding. If you don't mind paying for convenience, NLD can save time. Just be sure to follow their compatibility chart. Some newer firmware won't allow downgrading without NLD's tricks. Superpatcher, GitHub, open source scripts to mod firmware in a more customizable way. The Superpatcher project is community-driven and has a detailed README explaining each mod it does, such as enabling Galileo GNSS, disabling battery autoland, etc. Using it requires a Windows PC. It's a command-line guided process but very straightforward with on-screen prompts. Since it directly patches the FC firmware, it can enable features like inverted motor start that parameter tweaks alone might not achieve. Check the GitHub for the latest version and supported firmware. as noted, Inspire 2 is supported on certain versions. Forum communities. The DJI Inspire Pilots Forum, inspirepilots.com, is a goldmine of information. Threads like modified parameters for Acro flight detail exactly how one user flipped his Inspire 2 by disabling gyro/accelerometer on firmware 0.330. The forum's veteran members, like the editor, also provide cautionary advice, for example, highlighting the Inspire's lack of variable pitch making sustained inverted flight impossible. Searching that forum for keywords like Acro, manual mode, NLD, etc., will bring up posts from people who have attempted these mods. Mavic Pilots and Phantom Pilots forums also have relevant info because the parameter hacking techniques were first popular on those models, Mavic Pro, Phantom 4, etc., and much overlaps with Inspire 2. In fact, some Inspire 2 modders, like Brett8883 who made Super Patcher, are active on Mavic Pilots and share insights applicable across models. Facebook groups and YouTube. The i2mod Facebook group, facebook.com/groups/i2mod, is dedicated to Inspire 2 modding. Here you can find the latest experiments, ask questions, and see others build photos. YouTube also has demonstrations, e.g., search for Inspire 2 Acro mod or channels like SkyCamEE, who did a series on Inspire 2 mods. Watching an Inspire 2 flip on video is both inspiring and sobering. It shows it can be done, but also how quickly things can go wrong if inputs aren't perfect. Some YouTubers provide tutorials on enabling manual mode on DJI FPV/Avida drones which conceptually help understand Acro training, though those models are designed for it to an extent. GitHub and developer resources. If you want to dive even deeper, the DJI Firmware Tools project on GitHub contains reverse engineering info on DJI flight controllers and protocols. While it's more oriented to extracting/encrypting firmware, it can enlighten how DJI's system is structured. Also, the ArduPilot documentation has a section on ACRO mode, flight tuning, useful reading to grasp how a flight controller handles acro, rate control, versus stability modes. Even though you may not run ArduPilot on Inspire, the control principles are similar and you can apply that knowledge when flying manual. 5. Risk factors and warnings. Modding an Inspire 2 to Acro is inherently risky. It's important to explicitly consider the risks. Flight risk. You will be flying a 3+ kg drone with no self-stabilization. If you lose orientation or overcorrect, the Inspire 2 could free fall or shoot off unpredictably. Crashes can be catastrophic, for the drone and anything, or anyone, it might hit. Always test in a wide open area, far from people and property. Start with small attitude limit increases before going full manual. If possible, practice Acro with a simulator or a cheap FPV drone before unleashing the Inspire. Hardware stress. The Inspire 2 wasn't engineered for stunt aerobatics. Aggressive flips and stops put huge stress on the frame, motors, and ESCs. The battery mod, LiPo Caddy, allows more current draw, which can in turn push the ESCs to their limits. There's a chance of burning out a motor or ESC if you do repeated high throttle maneuvers that the stock system would normally prohibit. Monitor motor and battery temperatures. Consider a cooldown period between flights. Also note the gimbal is not meant to handle inversion, it will likely lock or go limp if the drone flips rapidly. Remove the Zenmuse camera when doing test flips to avoid damaging it, use only the FPV Cam for those flights. Warranty and support. Any firmware or hardware modification voids your DJI warranty, which for Inspire 2 is likely expired by now for most, but still. You also won't get official support if something goes wrong. There is a non-zero chance you could brick the flight controller when flashing unofficial firmware or messing with parameters. For example, setting the wrong value, like an out-of-range number, could cause the FC to throw errors or not initialize. Always have a recovery plan. Keep copies of original firmware, know how to boot the drone into recovery mode or use DJI Assistance firmware restore if available. Some modders use a second flight controller unit for experimentation, though Inspire 2 FC isn't readily swappable like a hobby FC, since it's integrated. Legal considerations. Disabling NFZ and altitude limits means you could potentially fly in restricted airspace or above legal altitudes. While the drone won't stop you, local laws still apply. Be mindful of regulations. Flying Acro at high speed near airports or crowds is not only illegal in many places but extremely dangerous. The responsibility lies entirely with the pilot when these safety features are removed. Use good judgment and only fly Acro in safe, legal locations, e.g., an isolated field. Mechanical limitations. As stressed before, the Inspire 2 cannot sustain inverted flight because its props don't generate lift upside down. Any flips must be transitional, rotate 360 degrees quickly and recover upright. Don't attempt to hover inverted, you will drop like a rock. Additionally, the Inspire 2's design, folding landing gear, etc., means certain orientations could cause arms to move if the landing gear logic got confused. Make sure landing gear is set to manual control, not auto, so it doesn't accidentally toggle when the drone tilts. Keep the landing gear down or up consistently during acro to avoid mid-air transformation. And note that if you do extreme pitching, the battery locking mechanism should be solid. Ensure batteries or Caddy are secure, as high G flips could eject a poorly secured battery, which would be game over. Community help. Despite the risks, many have successfully implemented these hacks by learning from others. Engage with the community resources mentioned. Often you'll find answers to issues, e.g., drone won't take off after parameter change or getting compass error after mod. For instance, one tip shared is that after disabling accelerometer leveling, the drone might only arm in ADI mode, since GPS mode expects a functioning accelerometer. Little quirks like that can be solved by asking those who've done it. Always keep an eye on firmware updates and news. DJI might release new firmware, though Inspire 2 is now older, that changes things, and likewise the modding community might discover new tricks. For example, a future patch could allow 100% manual mode on newer firmware or an easier toggle. Conclusion. Converting a DJI Inspire 2 into a true acro flying machine is an advanced project that pushes the drone beyond its intended design. It involves software hacks, like downgrading firmware, editing hidden parameters to disable stabilization and limits, and using tools, drone hacks, NLD, Super Patcher, to unlock manual control. It may also involve hardware tweaks, such as adding a high-performance FPV camera system for real-time flying, upgrading antennas and power systems to handle the demands of acro flight. The result, as demonstrated by community experts, can be an Inspire 2 that flips and rolls on command, essentially turning this professional cinema drone into a massive FPV freestyle rig. However, with these modifications come significant caveats. The pilot must be highly skilled to manage a manual control Inspire 2, and they must accept the risks of potential crashes or failures. Mechanical and firmware limitations mean the Inspire 2 will never be as nimble or forgiving as a purpose-built acro quad, but with the right hacks, it can certainly approximate one for short exhilarating bursts, and the footage of an Inspire doing flips is undeniably cool. By following the best-in-class methods outlined, leveraging community tools and knowledge, an experienced hobbyist can unlock the Inspire 2's full potential. Just proceed methodically, make one modification at a time, test thoroughly, and maintain an utmost respect for safety. The Inspire 2 was built to inspire. With these mods, it can also thrill like a racing drone, giving you manual mastery over a powerful aircraft. Fly safe and enjoy the ride in acro. Sources: the information above was compiled from community forums, developer wikis, and first-hand accounts of Inspire 2 modders. Key references include Inspire pilots' forum discussions on acro parameter tweaks, the drone hacks and NLD documentation, and examples like the Skycam Inspire 2 FPV mod project. The LiPo Caddy adapter benefits were detailed by its creators. For a deeper dive, see the DJI Super Patcher GitHub README, which lists many unlockable features for Inspire 2 and community guides on parameter mods. These resources reflect the collective knowledge of the drone hacking community up to 2025.